And you have your presentation up there, and I'm just going to introduce you quickly here. Alexander Pfeiffer is a recipient of a Max Cade Fellowship awarded by the Austrian Academy of Science to work at the MIT Department for Comparative Media Studies, a writer and former head of the Center for Applied Game Studies at Donau Universität Krems. And he is going to be presenting about blockchain technologies for the validation, verification, authentication, and storing of students' data. So go ahead, you are welcome to start.
Thank you very much for the nice introduction. My colleagues for this work are Stephen Pezzina from the Ministry of Education in Malta, Thomas Wernbacher from Danube University Krems, and Simone Kriegelstein from the University of Vienna and the Austrian Institute of Technology. I learned from my experience speaking about blockchain and smart contracts at non-tech conferences that there is a need to provide some basics in regards to blockchain and how it can be used to secure data sets like certificates in our case. So I will spend like 5-6 minutes on the basics, and then I will look into our project. So when we talk about blockchain systems, and let us leave possible frauds aside for now, because this is another big discussion, trust is always the main objective. We need transparency, while at the same time maintaining privacy. That means private information in the form of metadata remains private and encrypted, and only the proof of the transaction is visible. And it is often important to provide automation, and this is where smart contracts come into play. These are ideally connected with a digital identity of the sender and receiver, and we talk about this in a minute. So in short, we use blockchain technologies when we no longer need an intermediary, a middleman, but blockchain systems take over this particular role. And we use blockchain systems when we want to store information, or at least the proof of a transaction, permanently and verified by all the nodes. You often hear the term digital ledger technologies, DLT, but what is the difference to blockchain? Blockchain technologies are a subset of the generic term DLT, and with blockchain, the transactions are bundled into blocks, depending on the system. For example, after a certain period of time, a certain number of transactions, an amount of reached data volume per block, or a mixed form of all of that. The stored data set, meaning the block, is given a hash value and is therefore unique in its form. Therefore, no transaction can be changed retroactively, or only in extremely rare cases if the majority of the computing power, simplified said, the computers in the network and the owners would consent. A hash function is an image that maps a large input quantity to a smaller target quantity, the hash value. And here you can see an example. Starting with the first block, the Genesis block, a hash value is generated based on the information in the dataset. The timestamp and a random value is integrated, and adding a random element is called salting, and this is very important to keep those hashes unique. With this hash value, the second dataset starts and generates a new hash value. This is how the blocks are linked with each other. The completed blocks cannot be changed, and the current block here in this case is waiting for a new transaction to be generated. You can look into all those transactions on the several blockchains using a block explorer, an internet website, but please be aware that this is only a website that is run by some person or a company. So even this information on the website can be altered, but for a first look, it's okay to use this. But if you want to be 100% secure, you have to run your own node, which means a full copy of the blockchain, all the transaction, their hash values synchronized with all the other nodes of the network. Then you're on the safe side. Blockchains can be public, consortium-based. That means, for example, between different partners. A good example would be between different banks in different countries. Or private, if we use again the example of a bank, between one brand of a bank, like for example UniCredit, and its different branches. And furthermore, blockchains can be with free access. This is called permissioned, or restrictive, so everyone has access. so that not everyone has access, which is called permissionless. And of course, there are also combinations, and this is a good solution to be GDPR compliant. What is important is that there are different kinds of tokens based on their usage. And let me just discuss two of them. One is the cryptocurrencies. So those are the tokens like Bitcoin, Litecoin that you maybe know. They should store a store of value. But we will talk about non-tradable utility tokens. And those are tokens where we do not want them to be freely traded or sold on the market, for example, storing a grade or a certificate. On coinmarketcap.com, you can have a first look into which different kind of blockchains and tokens exist. So talking about smart contracts, a smart contract is starting the automatization process. And I'd like to give you just two short examples. For example, you allow your car to pay the fees for parking automatically. And then in the smart contract, if your bank account is not funded properly, then you allow the owner of the parking space, for example, to block your engine and your car. You can secure all kind of real assets like paintings with a token that proves the ownership, or you can do your last will on blockchain, for example. One project that Danube University did is that we tried a social network based on blockchain, where every like generates value. And in this case, we generated value worth like 1,000 euros in the end of 2017, and we used that for example, to fund tablet PCs for a school in Brazil. So this is, for example, how new forms of social media can be generated. And of course, blockchain can be used in the COVID-19 crisis. Here you find an article on the MIT blog about it. The problem that we have is that on the one hand, we have identity, and on the other hand, we have the secure storage of data, and we need to find ways how to combine both. And in regards to identity, you all know the classic passport, of course, secured by biometric data. We know social networks. We know that we can easily fraud identities there. And even if you have a verified identity from Twitter, those accounts can be hacked. You have identities assigned by your bank. And then in the European Union, we have the eIDAS regulation using all these digital identities provided by your governments, and they should be accepted from one country to another. And although this regulation is out there for 6 years, it's not working how it should work at the end of the day, because some agencies don't know that this regulation even exists. So people were trying to create decentralized forms of identity, like the Sovereign Foundation or the W3C Foundation, and you can create applications that is compliant, for example, with W3C. So it's something that we are doing. We combine the SSL certificates with digital identifiers to be sure that someone working, for example, at Danube University has an identity, and the proof is the SSL certificate. And then we generate a blockchain-based identity using a digital identifier. And at the end, it would look like this. This is called the electronic IT wallet. So you have your wallet storing or having access to all your different kind of possible proof of identity. And as a tokenized, you have metadata or tokens storing encrypted data. For example, in our case, a learning credential. And then you can combine this token with the learning credential with your digital identity and can give access to third parties, for example, verifying that your certificate is actually a real one. And this is something for another talk, but something we are also working on at the moment is how can we give digital agents, AIs, that work on our behalf access to all this kind of information. So now the second part of the talk is actually using blockchain technologies in the educational sector. And there is one famous approach from MIT, it's called block certs. But block certs is only verifying with a so-called one-way hash that a document is a unique document. And it is not storing the metadata. So for example, the grades or any private data, it just says, okay, this PDF has this hash value, and we on blockchain that this hash value is an original in that school or university. So Our main idea is that we start to even store metadata on blockchain. So this metadata can also be verified and shared between different entities. And in a survey or looking into desk research where this kind of metadata on blockchain can be used, you can say you can use it for school internal votings, for the scholarship management, for the enrollment process, to secure the SAT results in the US, for example. So our applied project, we started 3 projects. One is a game-based learning and assessment project. The other one is e-learning and assessment. And the third one is in-person and online conducted exams. And let's start with the third one. So the main question for all of those 3 is, where do we start the chain of trust that this identity is true? And in our case, it would be like a country issuing a digital ID to a school, the school issuing a digital identity to the teacher, and of course all the students have a verified ID. So we have these identities stored on blockchain, and we have the grades and the certificates, the exams, whatever, stored as tokens, as an additional message attached, encrypted to tokens. If you
5
create,
minutes left.
Yeah, if you create such an ecosystem, it's a quite complicated structure of tokens. This is just a very quick example. If you need any help in designing such a system, just contact me. I have quite some experience. But in regards to starting the chain of trust here, we have a message sending from the blockchain account of the university to the same account with, for example, here the list of the enrolled students. And on the other hand, you can have, for example, a tweet verifying this is the blockchain address of the university. But of course, it would be much better if there is a list on the university website, or if there is even a centralized register where all the universities of a country, for example, and their blockchain addresses are registered. And as I said, we're talking about utility tokens that we do not want to be sent between different parties. So we need to send up so-called approval models, that every time someone wants to do a transaction, in our case is the student and the issuer of the certificates, would have to give the okay, so that there is a transaction on blockchain, so that the tokens and the grades cannot be sent widely between the accounts. So in this case, we did 2 tests. One was a written test on Moodle. The other one was a verbal test just on Zoom. And then we created in a classic way our certificates using Moodle. But we also created blockchain-based transaction, which show the non-encrypted digital proof that this is a certificate issued by the university. Then we have encrypted data. Only the university and the learner have access. Also here with the transaction hash. That is encrypted metadata on the token. And then we also implemented some sort of gamification. And the second example, which is the more complicated part, is that we created a serious game for learning and assessment. So when you start the assessment part, you have to confirm that now there is an assessment going on. And this game was on the topic of arts. And when you finish the game, and here, for example, we have the metadata, 300 seconds, then correct answers, and an A grade. And then immediately this metadata is transferred on blockchain. So here the learner can put his private key. He gets access to the data. You see it's the exact same data the game showed you. It generates a shared key. Then you can, so here again, you have the exact data as given in the exam, but then you can use the shared key to give, like, for example, your future boss access to only this particular set of data. And the third part was a quiz that was quite similar, but here we created a unique token, a so-called singleton token for every exam, which gave us the opportunity to also use the so-called token properties to write information on, and not only the encrypted message on the token. So each token has the same name, but a unique asset ID. After an exam is passed, the token is created on the network. The message is attached to the token, encrypted. The token is transferred to the learner, to the teacher, to for example, and then we set up approval models. But what you always have to have in mind working with blockchain, working with identities, is that there are still humans involved, and humans tend to make mistakes. Humans tend to be bribed to fraud grades. And this is something that not even the best blockchain can prevent, but it can help that we find those frauds and we find the people behind. So thank you for listening, and of course I'm ready to take questions, and on ResearchGate you find most of my research related, or our research related to this topic.
Thank you very much, Alexandra, for your presentation. Very interesting. Now we open up for questions. I can ask a question while you are getting your questions ready. One thing that I think about when I listen to all of this is the GDPR things to consider. How could that interfere in all of this?
So that is the combination of using a private blockchain and a public blockchain. So you would store the sensible data on a private or consortium blockchain, for example, that is shared between the ministries of one country. Mm-hmm. And then, for example, after a certain period of time, for example, every 10 minutes, we just create a hash of this private data, so just one unique hash, and we share this hash with a public blockchain. So up to this point, the private data that it has not been altered would be verified. So of course, like in every 10 minutes, someone can put alternative data in the data sets, but at least we would secure it in that way. So we separate the private data from the public data. I think this is quite a good approach. And if we still believe in governments, and if we still believe that there are ministries, then and of course, if you are the learner and you run your own node with all the verified transactions of your credentials, you would always have the proof of the hash itself, and you would be the owner of the data. And this is the most important aspect here, that in regards to our approach, we like to give ownership of the grades back to the learner. And on the other hand, give the learner the opportunity to share that this is a legit certificate, a legit grade, to whomever they like to share it. Because this is the main problem here. So for example, I have an MBA from Alaska Pacific University, and it says it's an original printed on blue paper. And then I started another PhD, and I went to Malta, showed them my certificate, and they just put the piece of paper, put it in the light and said, oh, it's printed on blue paper, it's legit. But I could have frauded it easily. So they did not call the university if I really have this degree. And based on blockchain and using digital identities in a proper way, we could verify information and grades just with one click at the end of the day.
Great, thank you. Any questions that have been arising here?
It's a tough topic, especially if you are not a blockchain professional.
Yeah. But I have a continuing question on this. If I would apply for a job and I want to show my credentials through this, could they save it somehow and keep it?
Well, they could, of course, make a screenshot, but then the screenshot would not be verified with a hash. So the main idea is that we in our system created a shared keys, but the next step would be that also the shared key is secret and not readable for humans. So you as a user can, in your front end or in your backend as a user, generate like linked to an email, and based on the shared key, a permission for an email address to have access to the information, for example, for 1 week or for 1 month. So we would generate sub-shared keys that you as a user can assign just to email addresses to give access. There is, in Austria, it's called the electronic safe, so to say, the e-Tresor, and they use the system already for sharing PDF data. But of course, someone like with Snapchat can make a screenshot, and then they would have a screenshot, but this would just be a picture, and they would not be able to verify that this is a real picture and that that this is a real great. So if you do not look into the blockchain and into the digital IDs and do your work to verify that this is a true information, you can of course still fraud such systems if the human controlling it is not digging deeper.